parameters used in this work are temperature, pH, ammonia. Sensor actuation conductor by CC3200 is used as data processing device as well as server. Android app is used as a terminal device. A user can monitor the water condition using the Android app through Wi-Fi within the Wi-Fi range and through the internet from anywhere in the world. Some analysis is performed with the 4 parameters to determine the overall approximation condition of the water and the required action. The objective of this project is to design and develop a smart time real-based water and temperature, pH, and ammonia monitoring system. The system implementation resulted in a monitoring system that collects the water current, temperature, pH, and ammonia from the core controller in a real time. Also, the system provides and displays the information that includes a normal range, maximum and minimum, average, and finds the collected data which figured by the IoT platform. It provides a decision support to assist and guide fisher flocks in avoiding to distress the growth of fish and obtaining the optimum water monitoring data such as temperature, pH, and ammonia range. IoT is the very fastest growing technology, and the fields of IoT is extended its wings in every one of the areas today. With the progression in the computers, the innovation is achieving the ground level with its application in the aquaculture. In this work, we have automated monitoring of water quality of aquaculture using CC3200 various sensors and other applications. System bundle is installed in the fish farmer terminal equipment to allow the administrator to monitor the fish farm status. A query of history is designed in the transmission of section to greatly reduce the equipment, manage and labor cost, and also increase the productivity in the fish farming. Carefully monitoring of water quality parameters is important to understand the interaction between the parameters and effect on the fish and their growth and health. The current system includes the CC3200 board, one of the small board computers that consumes very low power and widely available, and the connected to the control unit to various sensors for monitoring.
The main advantage of our project is that it monitors and provides the solutions to all the problems that are observed in the adverse conditions. The project is based on IoT, so it can share and monitor the data simultaneously. The customer will get all the information about water conditions without any guidance. The sensors we use in our project gives the idea about the water conditions and according to which solutions can be taken. Our project is completely user friendly, so further complications is minimized. Our project is cost effective when compared to the other products in the market.
We deal with couple of sensors in our project, mainly pH sensor. We use 4502C pH sensor in our project. This pH sensor works when the top head of the pH sensor dipped inside the water. This pH sensor requires 5 volts DC power supply, and the service life of this sensor is 3 years, and its range is -10 degrees centigrade to 50 degrees centigrade. And we also use temperature sensor in our project. By using this sensor, we can note down the water temperature readings. The temperature of water mainly controls the amount of oxygen levels in the water, so noting down the water temperature is very important. And we also use MQ137 sensor in our project, that is ammonium gas sensor. This sensor will check the purity or freshness of the water. When this sensor reading is very high, that means the amount of dirt or impurity in water is very high, which is not suitable for fish life. If this sensor reading is low, that means this water is very useful for fish life. If the reading of the sensor is high, that means we need to recycle the water. All these sensors, temperature, pH and MQ137 ammonium sensor readings are noted down through app monitoring. We will interface a mobile and noting down the readings.
This is the prototype which we have developed. Here we are using a system which floats on water. This system moves in all directions with the help of aerators on both sides. We have assembled the temperature sensor, pH sensor, ammonium sensor beneath so that when the system is placed in pond the sensors measure those parameters respectively. Here we are using an ammonium gas sensor placed on upper side of the prototype with the help of a pipe that is immersed in water. Hence all the measured parameters information is sent to user if they deviate from required level of aquaculture.